Today, our team will be presenting on a topic cloud computing fundamentals, virtualization, and deployment models. I'm Jeevan, and here are my teammates. These are the contents will be explained in today's presentation. A Netflix case study to understand the deployment models in a practice. Netflix is a perfect example. As one of the world's largest streaming platforms, Netflix serves over 250 million users across 190 plus countries. Originally, Netflix relied on private data centers, but in 2008, it began migrating fully on Amazon Web Services. Today, its infrastructure runs on 100% on AWS, making it a successful case of public cloud adoption. Netflix chose the public cloud because of elastic scaling, cost efficiency, global reach, as well as a public cloud was too costly and lacked flexibility. When it comes to elastic scaling, it can handle sudden traffic spikes. For example, when a popular series is released and scaled down afterward. When it comes to cost efficiency, instead of maintaining the idle private uh, servers, Netflix uses AWS pay as you go model, uh, turning capital expenses into manageable operational cost. When it comes to global research, AWS data centers around the world allow Netflix to deliver content closer to users, reducing latency and improving the streaming quality. While the hybrid cloud added unnecessarily complexity, so the private cloud was most strategic choice for a Netflix business model. When it comes to virtualization method, virtualization is the foundation of a cloud computing. Among various methods, full virtualization is widely recommended for enterprises. It because it uses the hypervisor to abstract the physical hardware, allowing multiple virtual machines to run securely and independently. It supports legacy application without modification. It provides strong isolation and work with the enterprise tools like VMware and Hyper-V, and other methods like para-virtualization, OS-level virtualization, and full virtualization. When it comes to para-virtualization, which requires OS modifications, not idle for most setups. And OS level virtualization is like containers which are lightweight but share the same kernel and offer weaker isolations. Full virtualization gives the best balance of security, performance, and compatibility. This was my part, and further part will be continued by Sausanya.
I'll be showing the virtual machine that we have installed in the system. My system has Windows operating system. We have installed VirtualBox as our hypervisor. This is the hypervisor. We have Ubuntu client and the Ubuntu server, two VMs on our system. These are the Linux servers. So this shows that we can run multiple operating systems on a single system using the virtualization. Ubuntu, let me run uh, Ubuntu server. Until it gets open, I'll give an overview of the resources that we have allocated for the Ubuntu server. The name of the VM is Ubuntu server. It has the operating system Ubuntu 64. It is in the group 1. Its base memory is 20,048 MBs, and the boot order is first floppy, then optical disk, then the hard disk. Then the video memory is 16 MB, which is enough for just showing the Ubuntu server has opened. Let me show you. This is the Ubuntu server. We can also run Ubuntu client. Both the virtual machines can be run at a time. In the same way, we have allocated resources for the Ubuntu client also. The base memory is 4019 is 96 MBs. It has two process. We have allocated two processors for it. We have 20 CPUs in the system. We have allocated two for it. The boot order in this for this VM is hard disk, floppy disk. The EFI is enabled for this. The video memory is again 16 MB for this also. The graphic controller is VMSVGA. The remote disk it has opened. We can see that the virtual machine Ubuntu server is running on my system, which shows that we can use multiple operating systems in a single system by the use of the virtualization concepts. This is very helpful in the modern days where we want to use multiple operating systems. Uh, Let us wait until it starts. I'll show you what all features we have in this. We can take screenshots inside a machine. The If I want to take the screenshot, I can't take it from the host machine. I have to take it from the virtual machine itself. It is asking me for the login. I'll give my credentials. Yes, I went wrong. We have successfully landed into the Linux operating system inside the Windows operating system, which is a success of the virtualization. Thank you.
Thank you, Saujanya. Here is the architecture diagram. This diagram shows the overall virtual machine architecture. At the base, we have the physical host system, Windows, Mac OS, or Linux, anything. On top sites, the hypervisor layer, VirtualBox, or a VMware. Above that, we have two virtual machines. One is a server virtual machine, which runs web services and databases and allow SSH access. The client virtual machine used for application development and testing. This setup ensures complete isolation between virtual machines, efficient resource sharing, network virtualization, and easy backup through snapshots. Cloud fundamentals. Coming to the cloud computing part is cloud computing is built on some core principles. Hardware abstraction. This says virtualization hits the underlying hardware, enabling multiple OS environments on a single machine. Resource isolation. Each environment is isolated, preventing issue from spreading. Elasticity and scalability. This says resources can scale up or scale down as needed. And multi-tenancy. Multiple independent users share the same infrastructure securely. Optimization. Better utilization of hardware reduces infrastructure costs. These principles are what make cloud computing powerful and flexible. This was my part. Next will be continued by Tezwin.
I'll be explaining about the practical applications. In real world scenarios, virtualization and cloud computing are applied in several ways. For enterprise use, development and testing environments, legacy application support, disaster recovery solutions, and training platforms. And for cloud provider services, examples include AWS EC2, Azure Virtual Machines, Google Compute Engine, and Digital Ocean Droplets. These services offer faster deployment cycles, reduced hardware cost, improved disaster recovery, and enhanced security through isolation. The next slide is about key findings. Our key findings are from this study are Netflix's example shows how the public cloud enables scalability and global operations, and full virtualization remains the enterprise standard, balancing security and performance. Our hands on implementation validated theoretical concepts and emphasized careful resource planning. These skills are directly applicable to modern cloud platforms, forming a strong foundation for advanced technologies. The next slide will be continued by Vinay.
Thank you, Tejaswini. In conclusion, we analyze the real-world cloud deployment strategies, compared virtualization method, implement virtual infrastructure, and explore how these concepts tie into core cloud principles. As next step, exploring concatenations with Docker and Kubernetes, as well as automated with tools like Terraform or Ansible, can help build on this foundation. This presentation highlights how cloud fundamentals and virtualization are essential skills in today's tech landscape. Thank you. Thanks for listening. We hope this presentation gave a clear understanding of the cloud computing fundamentals.